Alright, boys and girls, welcome back to the drive-through. This is everything I can teach you in about 7 minutes about logarithms and exponential growth. Now, you've all already learned this in Algebra 2, but this is an important topic, and we are going to revisit it in pre-calculus. Okay, so what are logarithms used for? Logarithms are, in essence, used for when we have a variable as an exponent. So you could maybe use mental math to solve that. And what if we had 3 to the x is 81? Maybe you would know x is 4. But here's one thing you should consider. What if it was this? See, we don't know how to solve that without guess and check, guess and check, guess and check, guess and check. So someone created this property, or this, I guess, an operation called logarithm. So here's how it works. Identify the base. So 3 is the base of this system right here. So then you would say log base 3, and then switch the other two. Of 40 equals x. That is your answer. Now, what does that number represent? Well, I don't know. Based on our other information, I would say it's between 3 and 4. Let me turn on this calculator and show you how to do this. So if you go to math and then go over to number, hold on, actually just from math. If you just go from the math, it's choice A. See that? And now I can just type in log base 3 of 40, and there it is. So x to the 3.35776278 power is 40. Okay? So that's what logs are used for. Now let's learn a little bit more. So here's some rules for logs. First of all, if you just see log of 6, they're really saying that's log base 10 of 6. So if you don't see a base written down, it's base 10. If you see ln of 5, that is log base e of 5. Okay? And I'm not going to get too much into e, but we will get way into it when we get into calculus. E is a number. Consider e to be like pi, or radical 2, if you will. Okay? All right, what else? If we have log base 5 of, let's say, 6 times 5, we could rewrite that Okay, so if you had a situation like this, you could rewrite that as log base 5 of 6 plus log base 5 of 5. Why would you want to do that? Well, it's really going to take place mostly when you're solving equations. We're going to want to combine things or separate things. Similarly, if you have log base 3 of, let's say, I don't know, now I'll use variables, x divided by y, well, the division will turn into subtraction. So that's the log base 3 of x minus the log base 3 of y. Finally, if you have, let's say, the log base 7 of x to the 7th, well, since multiplication turns into addition, then exponents turns into multiplication. If you just kind of think this through, but I'll just tell you, that would be the same thing as 7 times log base 7 of x, okay? So that's a lot of rules reviewed real quickly, but I'm just trying to save you guys from having a super long video. Okay, exponential growth. Let's say year 1 we have 2 rabbits, and then year 2 we have 4 rabbits, and then year 3 we have 8 rabbits, and then year 4 we have 16 rabbits, and then year 5 we have 32 rabbits, and then year 6 we have 64 rabbits. This is exponential growth. We are multiplying each new entry, okay? The general formula for exponential growth is y equals b times r to the n power, or to the x power, okay? B is your y-intercept, and r is your rate of increase. or decrease. But keep in mind, that's going to be a positive number. If we decrease by 10%, then we're going to multiply by 0.90. But I'll help you with that as we go, okay? So what would this be? Well, we would need to find our y-intercept. How do we find our y-intercept? We always put in a 0 for x and then work backwards. And so it looks like our y-intercept would be 1. So this equation would be y equals 1 times, well, it looks like we're multiplying by 2 each time. So that is our r times 2.00, like 200%. You'll see it like that sometimes, to the n power. Now put in n. Well, here, I'll just put this in. So if I put it in my calculator, y equals 1 times 2 to the x power. Now let's look at my table. Bam! Look, it matches up perfectly. So how many rabbits will we have in 100 years? Well, let's go to our table setting, and let's start at 100, and let's see how many we have. Second table. Oh my gosh, we're going to have 1.3 times 10 to the 30th power. That's like, I don't know, the biggest number you could probably think of, amount of rabbits. We're going to need to call these rabbits. All right, keeping on. Not wasting your time this year. So, express as a product. What does that mean? Well, that means turn this exponent into multiplication. Oh, okay, so that's the same thing as 4 times log base c of t. Okay, we took away the exponent and turned it into a product. Why? Because they told us to, and we're just following directions. Express this one as a product. Okay, natural log, so this is the log base e of the 6th root of 9. Well, we don't know what that is. We don't have any rules for roots, but we can write it as the natural log of 9 to the 1/6 power. Aha! Remember that the 6th root is something to the 1/6 power. So if we want to write it as a product, that's 1/6 times the natural log of 9. That's how you'll do that problem. Rewrite as sums or differences. Oh, okay, this is a natural log. So this is going to be the same thing as the natural log of x to the 4th plus the natural log of y squared plus the natural log of z. Why does it work out this way? Because this is all about exponents. And if you remember, like when you do x squared times x to the 5th, well, you get x to the 7th. You add the exponents. So we're just kind of following those same rules, okay? How do we solve this one? Well, there's two ways to solve this. Well, you can use the change of base formula. So again, which one of these things is the base? It's 9. So once you identify the base, then you say 9 to the x equals 1/3. Oh, well, that's not very easy for you to think about. It's going to have to probably be a negative power, but that's okay. We can just do this in our calculator. So hit math, and then under math, go up. I go up because it's quicker. What? Math, log base, enter. Why is that happening? Let's turn this off and start over. Uh-oh, struggling here. Let's pause the video. Let's try it again. All right, so if we go math, and then go up to log base. Here we go. Log base 1/3. No, log base 9 of a 3rd. Log base 9 of 1/3. Enter. There it is, -1/2. So that means 9 to the -1/2 power is 1/3. Don't believe me? Try it. 9 to the -0.5. Bam, 1/3. Okay. I think I got one more thing to show you, maybe. Okay. Solve for x. So, all right, this will have to use the change of base. Which one of these things is the base? The 3 is. So log base 3, and then switch the other two sides of 31 equals x. Oh, we can do this. Math, log base 3 of 31. 3 to the 3.1257 power equals 31. All right, I hope this helps. Boom!